When we think about the backbone of our global economy, we often picture container ships, maybe delivery trucks, those amazing robots and fulfillment centers. But there's an unsung hero, right? A fundamental element that makes all of it possible, yet it's almost entirely invisible: light. Specifically, the surprisingly complex and, well, absolutely critical art of lighting a warehouse. Welcome to the deep dive. Today, we're taking a really close look at the fascinating, intricate world of effective warehouse illumination. We've pulled together a rich stack of sources for you guys from places like the Illuminating Engineering Society of North America, IESNA, and the Society of Light and Lighting, SLL. Plus, specific product and design insights from industry leaders, folks like Ansell, Alcon, Thorne, RDI, Philips, and Unilamp. Quite a list. Our mission today, it's pretty straightforward: give you that shortcut to being genuinely well-informed. We're extracting the most important nuggets of knowledge about how these massive, diverse spaces get lit. Get ready for some serious aha moments, I think, that will fundamentally shift how you think about illumination in industrial settings. Okay, so, when I first picture a warehouse, I often just see this vast open space, just huge. But the reality is the lighting needs must be incredibly diverse depending on what's actually happening inside those walls, right? So what are the core visual tasks designers are really trying to illuminate in these environments?
That's a great starting point because the key insight here is that most critical visual tasks in a warehouse don't just happen on the floor. They occur on two essential planes. There's the horizontal, obviously for general movement, getting around safely through aisles, but then crucially there's the vertical plane. Imagine trying to read a label or find a specific product on a shelf way up high, effectively lighting those vertical surfaces. That's often the more challenging, yet absolutely essential requirement for safe and efficient operations.
That distinction makes a lot of sense. Yeah, see where you're going and see what you're picking. So how do lighting designers tackle this dual plane illumination challenge, especially with those really high ceilings we often associate with warehouses?
Exactly. For those classic big open areas with high ceilings, maybe over 6, 8 meters, the traditional approach used pretty basic symmetrical lighting. But modern solutions have really evolved. Now we rely on robust, high-performance LED high bay luminaires. These are often built tough, rated to withstand dust and moisture. And they're designed to deliver powerful focused light across those huge spaces, adapting to ceiling heights that can usually go from, say, 15 feet to over 40 feet.
Okay. And what about those towering aisles of shelves, the racking areas? I'd imagine just cranking up the overall brightness wouldn't quite work there. What are the unique challenges those present for lighting?
The racking areas, yeah, that's a completely different beast, really. Here, the priority shifts quite dramatically. Horizontal light is still needed, sure, for staff safety on the floor, but the real challenge is getting uniform, adequate light on those vertical surfaces all the way up and down the shelves. This is where linear LED solutions really come into their own. Many have specialized optics, things like anti-glare diffusers or mirror-finished reflectors designed to push light precisely onto the goods. And for exceptionally high racking, you'll find luminaires with very narrow, intensive beams, specifically engineered to get light down to the very bottom shelf with consistent brightness.
Right. So if you've got lower heights, maybe mezzanines or something, I'm guessing those same super high-powered lights would be overkill?
Precisely. Yeah, total overkill. For those more confined spaces like mezzanines or maybe lower storage zones, you typically use more compact, robust linear fittings, often non-corrosive ones. Regardless of the area, though, we're always focused on a couple of key metrics. First, illuminance, measured in lux. That tells us the sheer amount of light hitting a surface. Second, uniformity, making sure the light is spread evenly. You don't want distracting bright spots and dark patches. For example, industry best practices, like in the CIBSE Lighting Guide 01, LG01, people call it, recommend a minimum average illuminance of 200 lux for areas where people are working continuously. And that 200 lux isn't just arbitrary, it's about amenity. Basic comfort, visual ease for general tasks, preventing eye strain, making sure it's safe and productive without being, painfully bright or causing fatigue.
So it's not just about a bright bulb, it's really about how the light behaves in the space. And I read something fascinating about how the surfaces themselves, the walls, floors, ceiling, can play a huge role in this.
Oh, absolutely. The power of surfaces is definitely an aha moment for many people. Imagine a warehouse where everything's dark, absorbs light. Now picture one with a white ceiling reflecting maybe 80% of the light, and a light-colored concrete floor bouncing back 20–40%. In that second scenario, the lights aren't just working alone, they're collaborating with the building. The surfaces act like these giant free reflectors, bouncing light around so effectively that you might need significantly fewer fixtures, or lower-powered ones, to get the same brightness. It's not just about saving energy initially. It's a fundamental design principle for efficiency, reducing the total power needed right from the start.
Okay, so it's clearly far more involved than just sticking up some bright lights. Warehouses are incredibly dynamic places, right?
Hmm.
Filled with large machinery, sometimes extreme conditions, constant activity. I'd imagine dealing with deep shadows or specific safety risks in these bustling, often harsh settings requires a unique approach.
It definitely does. And this brings up a really important question. How do we make sure the lighting actively supports tasks and protects workers, not just provide general brightness? Dealing with physical obstructions, harsh conditions, yeah, that requires a specialized proactive approach to keep everyone safe and things running smoothly.
I can easily picture huge machines like forklifts zipping around or overhead conveyors casting these massive shifting shadows. How do designers tackle that?
Obstruction management is absolutely critical. You're right, large machinery, conveyors, cranes, even lots of pipework can create really significant shadows. These can make tasks difficult, even dangerous. So designers use clever strategies. Instead of fewer, very powerful lights, they might use a greater number of smaller wattage luminaires. Spreads the light source out. Staggered layouts are common too, making sure light comes from multiple angles. Sometimes they even mount supplementary lights, they call them boom lights, directly onto cranes to light up the exact work area. The key guideline really is to aim for every point in the space to be lit by at least two luminaires. That dramatically minimizes those deep, dangerous shadows.
Makes sense. And what about glare? I've definitely been, momentarily blinded by bright lights in industrial places. It's incredibly disorienting. For someone operating heavy machinery all day, that must be a huge safety concern.
It's paramount. Yeah. Yeah, you've hit on a critical safety issue there. We differentiate between direct glare, which is what happens when you look directly at a bright light source. Think of a forklift driver looking up to place a pallet high up. They could suffer disability glare, which momentarily just wipes out their vision. Then there's reflected glare, which bounces off polished or glossy surfaces. To combat this, solutions include using low luminance fixtures with wide distribution, fitting things like louvres or diffusers, and importantly, using uplighting onto a reflective ceiling. That softens the brightness contrast. Also, just specifying matte finishes for floors and surfaces instead of glossy ones can make a big difference. It's all about protecting vision, maintaining focus.
Okay, now here's where it gets really interesting for me. I've heard about something called the stroboscopic effect, where machinery can look like it's moving differently than it actually is. That sounds like an incredibly dangerous visual trick.
It is incredibly dangerous. Yeah, the stroboscopic effect is this illusion where the rapid on-off flicker in a light's output, often from an AC power supply, can make rotating or reciprocating machinery appear stationary, or maybe moving at a different, often misleading speed. You can imagine the safety implications, right? A worker reaching into what they think is a still machine. So to mitigate this serious hazard, designers use high-frequency control gear for the lights, or they wire alternate lights on different electrical phases, which essentially tricks the eye by constantly changing the flicker pattern. Another approach is adding LED or tungsten halogen lamps, which have minimal light oscillation, to supplement the main lighting. The goal is always to break that dangerous visual illusion.
Wow, okay. And what if you're dealing with extreme temperatures or, say, flammable materials in the warehouse? That's a whole other level of challenge, surely.
Absolutely.
Yeah.
Yeah, that's where we get into hazardous and hostile environments. Each needs specialized lighting. Hazardous areas are those exposed to flammable gases, vapors, maybe dusts, think fuel industries, or certain milling operations where fine dust could ignite. These demand light fixtures specifically designed and certified to prevent any spark that could trigger a fire or explosion. They follow really strict guidelines, like the National Electrical Code. Hostile areas, on the other hand, are environments where the lighting equipment itself is likely to get damaged. This could be extreme heat near furnaces, maybe deep cold in cold stores, significant vibration from overhead cranes, or corrosive atmospheres. Solutions range from putting sensitive parts like control gear remotely to using anti-vibration mounts for the lamps.
So there are actual, tough ratings for how resistant a light fixture needs to be against this stuff. Dust, water, impacts.
Yes, and these are absolutely crucial. Ingress protection, or IP ratings. They classify how well a luminaire resists dust and moisture getting inside. For instance, an IP54 rating means it's protected against dust and can handle spraying water. An IP55 can handle being hosed down. Go up to IP67, and it's protected against temporary submersion in water. These ratings are non-negotiable, really, for ensuring reliability and safety in tough environments. And speaking of cold, Cold stores present their own unique, really formidable challenges. Lamps and fixtures have to be chosen specifically to start up and operate reliably at freezing temperatures, dealing with issues like difficulty starting or even ice building up on the fixtures and blocking the light.
Man, it sounds like such a complex balancing act, getting the right light in the right place safely, efficiently. But thankfully, technology has advanced so much, hasn't it? How are modern advancements, particularly with LEDs, transforming warehouse lighting, moving it from just a static utility into something more dynamic, more intelligent?
Well, if we connect this to the bigger picture, we're seeing a really profound shift. We're moving towards intelligent systems that use technology to optimize not just light, but integrated performance, energy savings, operational flexibility across the whole facility. It's a real game changer.
And the LED revolution is undeniably right at the heart of this. What's been the biggest impact there, would you
Yeah.
say?
Undeniably. Yeah, the LED revolution brought unparalleled advantages. First, incredible energy efficiency. Modern fittings often achieve well over 100 lumens per watt, some even pushing up towards 165 millimilliW. That's just a dramatic leap from older tech like mercury lamps, which are pretty much obsolete now. LEDs also boast exceptionally long lifespans, often up to 100,000 hours. That means far less maintenance hassle and cost. And critically, they offer precise optical control. You can direct the light exactly where it's needed with minimal waste.
Okay, so beyond just the efficiency of the bulb itself, how are these new LEDs becoming smart?
That's where intelligent control systems really come into their own. One major advancement is daylight harvesting. This is brilliant, actually. Photosensors detect how much natural light is available and automatically dim or even switch off the electric lights to maintain a set illuminance level. The aha here is your lights aren't just on or off, they're constantly adjusting, adapting, leads to substantial energy savings. Even simple open-loop systems, which only sense the daylight coming in, are very effective for this. Then there's presence-absence detection. Uses movement sensors, motion detectors. They switch off or dim lights way down in aisles or areas that are temporarily empty. Why light an empty space, right?
So if I walk into an aisle, the lights pop up and then dim down after I leave. That's pretty cool. Must save a ton of energy. What about flexibility in managing all these different zones and controls?
Exactly. And that's where wireless control truly shines now. Advanced systems like Philips Green Warehouse or Righty's Apison BLE in control use robust Bluetooth mesh networks. This means setup is much more straightforward. You can easily rezone areas wirelessly without needing costly hardware changes or rewiring. Facility managers can control things remotely via mobile devices, get real-time data, group lights dynamically. It's really about empowering them to maximize efficiency and adapt quickly to changing layouts or operational needs. Huge flexibility.
Speaking of natural light, are modern warehouses actually designed to integrate daylighting now, rather than just relying on artificial light all day?
Absolutely. Seamless daylighting integration is a key modern strategy. It makes so much sense. Incorporating strategically placed skylights or maybe translucent roof panels can provide ample diffused natural light. This dramatically reduces reliance on electric lighting during daytime hours, and it can lead to substantial energy savings. For example, one study showed a well-designed skylit fluorescent system saving up to 74% of lighting energy compared to a basic metal halide system with no skylights. Huge difference. The goal is always to maximize that free natural light while being careful to avoid direct sunlight, which can cause uncomfortable glare.
Okay, so beyond how bright something is or how evenly lit it is, I've heard about the importance of color rendering, CRI. Why is that so crucial in a warehouse environment? Seems like brightness would be king.
Well, Color Rendering Index, or CRI, is all about how accurately colors appear under that artificial light compared to how they'd look in natural daylight. It's not just about brightness, it's about the fidelity of the color. Does that red look like true red? And this is absolutely crucial for specific tasks where precise color judgments are needed. Think about someone grading tobacco leaf or selecting specific leather skins, maybe performing quality control in an inspection booth where slight color variations are critical, or even just distinguishing between the contents of different pipes based on their color coding for safety. For these critical tasks, a CRI of 90 or higher is often recommended for really accurate color work. General warehouse lighting might be okay in the 60-80 range. But for specific things like that tobacco grading example, you might even want a high correlated color temperature, maybe around 6500 Kelvin, combined with a very high CRI. It's the difference between just seeing a color and truly perceiving it correctly.
Right, okay. So what does all this mean for the people who actually have to design these systems? The engineers, the designers. It's clear that it's about much more than just, picking some light fixtures off a shelf. It sounds like a really holistic approach, considering everything from the initial concept right through to ongoing operations.
This raises that important question. How do designers navigate this landscape? It's complex, often conflicting requirements. It involves a structured, multifaceted process, really, balancing immediate needs with long-term performance, energy targets, and, above all, safety.
What are the main objectives they're juggling, then?
Well, designers have to start with a holistic understanding of the project's objectives and constraints. This means identifying all the legal safety obligations first. Then, doing a thorough analysis of all the diverse visual tasks, considering their size, the contrast, how long people do them, whether color discrimination is needed, the specific task plane, is it vertical, horizontal, any potential obstructions. They even factor in the desired mood or atmosphere for other areas, like canteens or restrooms, making sure it's a comfortable environment overall. And all of this has to be balanced against practical constraints. Budget, obviously, stringent energy consumption targets, like Part L of the building regs in the UK, and physical access limitations for actually installing and maintaining the lights.
And you mentioned maintenance. A complex system is only as good as how well it's maintained, right? How does that factor into the initial design?
Designing for maintenance is absolutely critical. It has to be thought about up front, because lighting systems inevitably degrade over time. There's lamp lumen depreciation, basically. Lamps get dimmer as they age, and luminaire dirt accumulation, dust and grime builds up. Both contribute to what we call light loss factors, or LLF. So proactive design emphasizes easy access to the luminaires, maybe using hinge columns that lower down or just positioning them strategically for cleaning. And establishing clear schedules for cleaning and lamp replacement is vital. It's also about economic lamp replacement. Often, lamps get replaced not just when they burn out, but when their light output drops so low that the system is less efficient than intended. At that point, it might be costing more in energy than a new lamp would.
Makes sense. I imagine emergency lighting is also a huge part of this, but it's probably not a one-size-fits-all solution for a sprawling warehouse complex.
You're absolutely right. Tailored emergency lighting is crucial, and it has to be customized to the specific industrial context. The real sophistication here is that it's not just about lighting the path to the exit, although that's essential. Different types are required based on potential hazards. You have general emergency lighting for safe, quick evacuation. Standard stuff. But then there's special location emergency lighting. This is designed to bring specific machinery or processes into a safe, stable state before people evacuate. Think about preventing a dangerous chemical reaction or a machine running uncontrolled. That can save millions and, critically, lives. And standby lighting allows essential, absolutely critical operations to continue even if the normal power fails. Self-contained luminaires, ones with their own batteries, offer flexibility, but it's important to remember those rechargeable batteries generally have a useful life of less than about 7 years. Needs planning.
Wow. All these sophisticated considerations must mean there are a lot of standards and certifications to keep track of just to ensure quality and safety.
Oh, they are absolutely essential for ensuring quality, safety, performance, all of it. Organizations like the IESNA in North America and the CIE globally are key technical authorities setting the benchmarks. Designers have to ensure compliance with things like UL listings, underwriters' laboratories for safety, particularly in the US, or British standards in the UK like BSEN 60598 for the luminaires themselves, BS 7671 for the electrical installations. There are also IK ratings for impact resistance, how much of a knock a fixture can take. For energy efficiency, certifications like DLC Design Lights Consortium or Energy Star are vital indicators of high performance. And for LEDs specifically, an LM79 rating signifies rigorous testing for performance and longevity. Tells you it does what it says on the tin. Even the humble light meters used for measurement need to be color corrected, so their response matches human vision and cosine corrected for accurate readings from light hitting at an angle. And they need annual recalibration for accuracy. It's a whole comprehensive web of standards ensuring everything works exactly as intended, protecting both the investment and, most importantly, the people.
So what does this all mean then? We've journeyed from, well, the fundamental need to just see clearly in a vast space, all the way to the intricate details of smart controls, environmental resilience, meticulous design. It's truly been a deep dive into an often unseen yet absolutely critical aspect of modern industry. It really shows how much thought goes into something we rarely ever notice.
It really highlights how effective lighting in warehouses isn't just about, making a space bright. It's about optimizing human performance, ensuring worker safety, driving energy efficiency, all through thoughtful, integrated design and applying advanced technology. Is really a testament to the power of deliberate, careful engineering.
So the next time you see a package being moved around in a warehouse on a tracking update, or perhaps even receive one yourself, Maybe take a second to consider the invisible symphony of light that made that journey possible. What other unseen systems around us are similarly complex and critical, yet so often taken for granted in our daily lives?